This is a very short video to summarize as a summary for the conclusion part. I just want to highlight a few things, like the topography of the surface, talk about the friction, wear and tear. Okay, how the friction will cause certain things, wear and tear. Alright, then different equations, for example the friction will have the Archer's wear equations, you need to know, and how does the lubrications will actually reduce the wear factor of a surface. Alright, the wear factor, if you remember, is the K, alright, the inverse K, wear coefficient. So the larger the K, the better it is, because it talks about the amount of volume. If I'm not wrong, you give me a while. I forget where it is already. Over here, alright, the larger the K, right, this means the harder a material it is. Alright, then the harder the material, then it's good. But however, if you were to apply to the K over here, alright, then it's 6K, I think. So K and K cancel, S and Y cancel. So all in all, if you were to cancel everything already, you should get the area, the contact area, V is equals to LA. Alright, this is the length of how the sliding of the length, where the amount of friction, because you're gonna move this material here, so the sliding distance L. Alright, and the contact surface A. The contact surface is not just this contact surface, it's more than that, it's more microscopic. The contact surface between all these asperatus. So the L, all these areas, and then you have the area. Alright, so all in all, if you cancel everything, the volume of V is the amount of volume being removed from the surface. Alright, so the K itself, the higher it is, the better it is I should say. Alright, because over here it doesn't being applied anywhere. Alright, the K is not applicable here because it will cancel with the H. So over here, the K itself talks about the hardness value just to take note of that. Okay, and then surface engineering process, the Cat 1, Cat 2, Cat 3 can improve all this surface wear and whatever stuff, and also to help in surface appearance. Alright, what are the design considerations of coating, which is the previous video. Okay, and take note of the surface contact may fracture, slide or yield under different types of stresses, shear stress or normal stresses. Okay, hopefully you're kind of clear, and therefore it deals with a lot of things that we have said. Or in total, what we have done is already from 9.1 to 9.16, 16 videos all along. Alright, you can just take a while to check it out. Alright, it's quite a lot of stuff, deep Brinell testings and equations, topography. So hopefully you kind of get a clear picture of everything, and hopefully the clearest picture is this one. Alright, introduction. Alright, categorizations, knowing the topography, the roughness, the asperatus. Surface contact talks about the Hertzian stresses, single contact and double curved surface, if you remember. I'll not go through here. Okay, and acceptable surface thickness, Brinell hardness calculation, friction, wear and tear type of equations over here. Take note of the testing equation is very important. And surface engineering process, we should have talked about it previously. So hopefully you kind of hopefully this is pretty clear now, and I think this is it, and next up is the tutorial. See you soon.